Okay, welcome back, everybody. This is the Virtual Residency Workshop 2021, Introductory, Intermediate, and Advanced. This is Tuesday, June 8th, the early afternoon session, and it's Assessing and Anticipating Researcher Needs. Panel, our moderator is Josh Jelinski from the University of Rhode Island, and I'm going to turn the microphone over to Josh. Josh, go ahead and get started.
Hi, everyone. Thank you for coming back after your lunch. My name is Josh. I'm here to talk about assessing and anticipating researcher needs, but it's mostly going to be the panel that will be conducting it. So we actually have a couple of prepared questions, and we received a couple in the chat. And towards the end, we'll be taking questions. So we have a fantastic panel, starting with Dana Strong, a senior information design specialist at the University of Illinois. She is a part of the web hosting team in the technology services, but also offers campus outreach through the research data service, the scholarly commons, the carpentries, and several usability and accessibility groups. We also have Jacob, an experienced computational scientist specializing in computational chemistry with an interest in HPC and cyber infrastructure for scientific and interdisciplinary computing. We have Deval on the line, who's a postdoctoral researcher working with the Wearable Biosensing Lab at the University of Rhode Island, with interests in assistive and rehabilitative technologies. We have Jim, who is the associate professor and director, analytics and artificial intelligence at the School of Business, the University of Charleston. Research centers around AI, big data, and social media analytics. And David, who is a research and education facilitator at the University of North Dakota. He's also an instructor in the School of Electrical Engineering and Computer Science at UND. And myself, a researcher with the Wearable Biosensing Lab, also at the University of Rhode Island. I have interests in AI and biomedical engineering. So what we'll do is we'll ask a couple of questions, and we'll have the panel kind of respond based on what they think, and we'll kind of see how that goes. So the first question to start us off is, what does it mean to you to assess and anticipate a researcher's needs, and why might that be important? And let's have Dana start us off.
Glad to be here. Hope that my network holds out. I think that is definitely the right order to have it in. I think that it's important to have assessment first and then have anticipation after that, because if you were here for the intake interview thing this morning, that is like my number one go-to foundational piece, is figure out what it is that they are doing and what it is they are currently working with and where the pain points are. So the assessment part is understanding what's going on, figuring out where potential improvements might be available. Anticipation is what they don't necessarily know to ask about. So I have a library science degree, and a whole lot of people don't think about things like archival data and data formats and data reuse over the course of 10, 15, 20 years from now until I bring it up. And so that is, I think, one of the places where assessment and anticipation can feed off of each other, but I don't want to think of it in terms of, come in with a preconceived anticipation of what you think they're going to need before you get a chance to listen to them.
All right, thank you. I guess we'll kind of go in a circle of the participants, kind of in the order. So I'd like to know, Jacob, what are your thoughts on that?
Yeah, so I'm pretty much going to add to what Dana said. I think assessing and anticipating is really important, but first assessing is very crucial. So that's when you get to, I call it taking the temperature, getting to know the researcher, knowing the person you're talking to, understanding the personality, and even knowing the vocabulary that they use and how you can communicate, interact, and better understand what they're doing. You can't do anything, you can't anticipate what their needs will be if you cannot access if you don't understand what they are doing. And to understand what they're doing, you need an assessment. And if you're working at an institution like mine, where you have very limited resources, you really have to anticipate what researchers will need. So it's important for me to even participate in hiring process, so I understand who is coming in, what they might be doing, what they may expect, and tell them what I have available. So that's the first contact. So when they come on campus, I pretty much have an idea or a sense of what they will be doing. And when I talk to not just one researcher, so I am at the campus level, university level, so I have discussion with multiple researchers. So I cannot fulfill all the needs at once. That gives me an idea to do some of the work in advance. So, and this is, I can only do this if I talk to the researcher, if I probe, if I understand them, if I know what they need. I understand where they're coming from, and more importantly, their personality, because you really need to know who you're dealing with and how you deal with that person.
Thank you. I'd like to know kind of how you approach that first informational interview then, so that with that researcher or the research team, so that you do get to know them, maybe if you don't have a previous background with them.
Is that me?
Yeah.
Oh, yeah. Okay, so
yeah.
Well, so if they do research, they probably have a profile, they probably have publications that they've made. A quick Google search will give you a really good sense of what that person is doing. And you just want to have an idea of what they're doing, and then a place to start the conversation, the icebreaker, as I call it. So, and then you don't go in blank. You go in having an idea, and you go in with the purpose of listening. You shouldn't be the one doing the talking. You should be the one doing the listening. And generally, I plan on asking questions that will enable me understand what the researchers are doing. And more importantly, I want to know how they do it, what they think they should be doing.
Okay.
Yeah. So from my discussion, I may reach out, I may have experience on some of the problems they're dealing with. I may not have solutions to their problem right away, but I may equally know where they can get even better help than I can provide.
All right. Thank you. David, I'd like to kind of ask you your thoughts on that, and then if that changes, whether it is a CS, limited or non-CS discipline, and how to work with those types of researchers.
Okay, well, like Jacob, I want to connect to the person first. I've only been in this role for about a year, so I don't have any preconceived ideas of what my clients need. Although I've been teaching high performance computing programming, in this first year, I've been exposed to snake files and Python on HPC systems. And that's something that I didn't consider as HPC, but certainly people are using using those tools on HPC systems. So I go in with my ears open.
Okay.
I think listening is really key to understanding their goals. If you don't understand their goals, then I don't think you're setting yourself up for success. But if I understand their goals, I get a better idea of how I can help. You know, some people are looking for data storage. More people are looking for data processing, but it's probably not parallel processing. There's a lot of people that just want to run faster, want to run their serial program faster on a faster system.
Sure.
I guess you asked about people who have a limited or non-CS background.
Yeah.
Okay. Well, again, as an example, I worked with a music professor in the last year, and he was looking for storage. He had lots of music files on flash drives and needed to get a better handle on them so that they could be backed up and he'd have them accessible. And he had a particular program that he wanted to use that had a graphical user interface from a Macintosh to the high performance system. And so I dug into that program and put together a user guide so that he would become comfortable with the transfer of files, and then eventually through repeated use become, quite productive just using that outside program. I would say for people who don't have a CS background, they're not going to program their own software. They're usually bringing some other program with them. And if I find that Linux is a hurdle for a fair number of people. They're coming from a Windows drag and drop environment.
Sure.
So anything with a desktop GUI that has a back end that can run on the HPC system is going to help them immensely. And I'm thinking of MATLAB. We recently installed MATLAB kind of in conjunction with our campus-wide license. And some people are really taking to that. And it's just a matter of them being comfortable. If their needs don't include MATLAB, I think some people who have a limited background, they don't want to write Slurm scripts to submit their jobs to the compute nodes. So snake files comes to mind. One of the first clients I helped wanted to use a program called Juicer, which is based on snake files for doing biomedical research. And the snake script generated Slurm scripts for each of the tasks that it had. And so this particular researcher doesn't have to deal with Slurm. He's comfortable with snake files, so that was the answer for him. As a third kind of fallback, anything Python or R related. People who have limited computer science background, Python is something that's more accessible than C or Java. R is even more accessible. And those have modules that can customize the environment for a user. And it works on the HPC system because those modules get installed under people's home directories. So it's easy for the system administrators. They just have to maintain a current version of Python or R, and the customized environment fits under the individual user's home directory.
Okay, thank you. Yeah, so those are really interesting points. So I really like that you said that you put together a manual for them. Adding additional documentation, especially for, the end user is quite a skill in itself, not just the technical side. So that's definitely useful. So kind of use systems that they're familiar with, and then try to reduce whatever barrier on the development of programming language, right? So you were suggesting Python or R.
Yeah, that's right. We cannot have an attitude that this is the way the HPC system runs, so you have to adapt. Yeah, that's not going to grow your research computing consulting business, if you will. We should be looking at ways to make it easier to bring people to HPC. I think facilitators have kind of a wealth of experience that if we could talk with developers of R or R Studio and help consult with them on how they can make their systems even more HPC friendly, it would benefit everybody. We'd have more research computing. We'd have more research going on.
I see. And Dana actually had a good point, but I think her internet is, oh, she just wrote something else.
I'm here. I didn't want to interrupt the conversation.
Oh, no, but please join in.
Okay. So one of the things that changed my life a few years ago was the discovery of something called BlockSpring, which is basically a visual interface for connecting up APIs. It was honestly harder to figure out how to get the API keys than it was to figure out how to connect things once they were joined up in BlockSpring. It used to be free. It was amazing when it was free. It is now a for-fee sort of thing, and I completely understand why. But there's lots of tools out there like that. Also low-code and no-code programming things that give people graphical interfaces so that they don't have to learn a language that is basically a foreign language to them before they can start working with their stuff.
Yeah, I like what you also wrote in the chat about teaching them to fish as far as your approach.
There's a team I've been working with for like over a year now, where one of the people is he's a French postdoctoral student, and he was very, very uncertain about technology when we first started partnering, but he is now basically the sole SharePoint admin, the sole wiki admin. He's like dived further into wiki scripts than I've ever gone myself, because he feels empowered and so enthused about what we're doing. And the way that I did that was, you know, we would build the thing together, and he would watch me make mistakes, and we would figure out what the solutions were together in our working sessions. And I would just, you know, like once we figured the thing out, I'm like, okay, let's hit record. Let's do a recap of the past 5 minutes. And we created a sort of custom documentation video directory for them that they could use for making their own text documents later or quick referring back to.
Yeah, hi Josh. Good afternoon, everyone. This is Jim Samuel. Can you hear me?
I can. I was going to call on you next.
Okay, but I'm just going to chime in on this question as well.
Definitely.
Just because one, I find it very important, and two, I'm coming in from the research side and I use the CI services. So I think I'll just throw in a few thoughts out there.
Definitely.
First and foremost, I completely agree with a lot of the points that David made and with the points in chat made by Dana. Excellent points. And that's pretty much described our experience over the past few years as we have tried to engage different HPC machines. So talking about R and Python, one of the most growing areas where we data it didn't work. Eventually, so the first time and it took me a few months from the point I got HPC access to the point where I was completely comfortable and I could run a batch job. And I think that's a huge inefficient, that was at that point of time. I saw that as a huge inefficiency in terms of ease of use. A few practical points. I don't want to repeat what David spoke, but I just want to qualify some of those things. R and Python, the challenge really is in the details. if we make R and Python, if these languages, just these two languages, these are the two dominant languages in big data analytics. If we can make these two to work on more HPC machines such that people do not have to learn how to work and master the Linux environment, then I think there would be a huge increase in the usage. The catch is in the details. It's quite easy to get to the home directory, install the base R, and run it. But for those of us who have been using R, we know that R is highly dependent on packages. And it's with the installation of the advanced packages and the dependencies, that's where the problems arise. The other aspect is data visualization. If we are not able to interactively work on the data visualizations, it creates a huge problem because most of the data scientists who are coming in from the data science background using R, that's the way they work. It's interactive, it's very visual in nature. Second part is Python, same logic, very easy to install base Python and run it on an HPC. The challenge arises when you need to run something like Jupyter Labs or Jupyter Notebooks. You need to load specific custom libraries. And I think these are open challenges. Just want to highlight that while a lot of the HPC, university HPC systems are doing much better with the GUI and point and click kind of interfaces, there still are a lot of challenges when it comes to making HPC easy to use. The best experience that we have tried both university systems as well as commercial systems, including Azure and AWS. The best system which has mastered it, especially with R, is AWS. Their sandbox and their environment works seamlessly. It's almost as though you're using a desktop. Every single package works. So in other words, the solutions exist out there. We need to ensure that we get our HPC systems to a point where the ease of use comes to a point where it's very easy for users, non-CS users, to engage HPC, and they should feel like they're just using their desktop machines. It's a lofty goal, but I think it's doable. And we, in fact, abstracted some of the challenges we faced, and we wrote a paper. It's been released as a preprint. I'm just going to post it into chat for those of you who may be interested. But I just want to emphasize, one of the keys is making it easy for non-CS users to use HPC. Thank you.
Yep.
Thank you. No, those are very good points, and making it both streamlined and easy, but also figuring out that those packages can be kind of tricky. Regarding that, in the chat, there's been a little bit of discussion, a plug for another training program called Data Carpentry, where they do teach R at universities, and using RStudio and Open on Demand for getting those visualizations you were talking about. And as well as for Python, Anaconda or Conda for the package management. These are good points. And actually, so we talked about a little bit about how to start the interview, and then kind of what you would be doing to work with the team. The next question that we had prepared was actually if you have a follow-up informational interviews, so the secondary interviews, maybe a little bit of work had been already taken place. How do you remind the team and the attendees about the previous decisions that might have had to be made, or the tasks that needed to happen, so that the project can keep on moving along when you have this large, potentially multidisciplinary team that also has technical requirements that are not necessarily understood by the people who need access to them. And on that, I think Deval is next.
Yeah, going back to that, when the second interview kind of thing, you already know the team or the individuals that would work on the project. You have a fair idea about their previous work and some experience. I hope you guys can hear me, right?
It's a little difficult to hear you. I'm sorry.
Oh, okay.
We really want to
Well,
hear what you have to say.
is it better?
Much better, thank you.
Oh, okay. I'm driving, so yeah. Actually, I'm not driving. I'm traveling, so it will be it is a bit going a bit difficult. Yeah. So I was saying that to have some idea about the team or the individual, now, according to the needs of the project, you want to understand what the person can bring in or what the person can put effort in your project or your task. Sometimes it happens that in the first interview, you are not much sure about the capabilities of the person. Then sometimes I do like to have present them, or I do.
We seem to have lost you.
Hmm.
We'll circle back to Deval in a moment. He's in transit, I guess. David, do you think you could start from there, please?
I haven't really, I think there's only one person that I've worked with on an ongoing basis. And
Sure.
that's been more consulting on software development rather than making any particular decisions on how to. I don't understand the science, and I don't quite understand, I guess, all the details of her work. So it's because, but it's a one-on-one thing, and we just have a pretty good communication. We don't have to really remind each other of any of what design decisions or technology agreements. We don't have any of that going on. So that I can't really contribute so much to this topic.
Sure. Yeah, so.
Shall I jump in?
Yeah, go. I was about to
Sure.
read your post.
Oh, okay, cool. Yeah, I am juggling so many projects simultaneously that I've got to keep notes, at least for myself, even if the rest of the team doesn't. So
Sure.
I make sure that I share my notes folders with the team that is working with them. And when we went on, I mean, I used to be like all whiteboard all the time when we were sketching things out and diagramming. And then we went, hey, here's everybody all online. What am I going to do for a whiteboard? Google Jamboard is awesome. You can write, you can draw, you can text, you can put in pictures, you can make sticky notes. It doesn't do the Trello type of thing where you can't really assign deadlines, but for freeform sticky note moving and scribbles and this goes here, this goes there, it's completely fantastic. And it doesn't get erased when you leave the conference room. It's right there. You can keep referring to it later. It has been amazing.
Sure.
Cool.
You're referring to the Kanban board, right?
Yeah. Like Kanban is what I would call Trello, Microsoft Planner, things like that, where you have specific columns of sticky notes. Google Jamboard is literally like a whiteboard, and one of the tools that it provides you is sticky notes that you can stack anywhere, including stacking on top of each other. So it's not quite Kanban style.
Okay, it's like build your own.
Yes.
Yeah, so
Like
I
an
think,
actual wall. Sorry.
yeah, so I generally would go the same way as Dana, but I would like to work with the researcher using their method of taking notes. If they like Google Docs or I don't know, Word, okay, fine, we'll find a way to share that. But generally, when I'm having a meeting with anybody, I always like to have notes because that serves really for reference. Because if you're hopping from project to project, you really need to take notes. So we take those notes together. They're free to add things that they think are important, and I keep adding it for all of us. And if we have a follow-up, well, a few days to the follow-up meeting, I will send a reminder, a reminder email with the link to the note, and just kindly remind them to go over it and set a few points for the agenda. If they have things that they would equally want to go over here, they should put it there. That's kind of what I like doing. But I equally wanted to touch a little bit on the HPC for non-CS. I don't usually like using the non-CS or non-computer science major. Because I have come across even computer science students who have very limited skills, but you can equally go across some students, I don't know, in the physical sciences or even in the humanities who are really good at what they do. So it all depends on their approach and how they really want to approach computing. And sometimes even using HPC scare people off. They hear HPC, they're scared. But I don't use HPC. I don't go to the term HPC until I fully understand how they're working. What are they using right now? Are they working on a desktop? Do you have their personal computer? What are the type of resources they have on there? The work that they're doing, is it good enough for that? Now, if they have limitations, yes, I'll probably direct them somewhere. Now, for people who hate using the command line, at my institution, I have a Jupyter Hub in Amazon Cloud set up with sample notebooks. Already, when you log in with your institutional credentials, it right there in front of you, there is a directory with sample notebook in there. You can go over it if you don't want somebody talking to you. And if you feel that there is you have some difficulties, okay, well, we'll help you. And I found out that Binder Hub as well is also a very good way to initiate people to learning. So if in a research group, they are working on, say, data analysis, they have a notebook, you can, you have an institutional Binder Hub, they have their notebook set up there with a link that they can share, even for beginners. They can go in there and try play with some of the commands that are in there at their own pace, and then try working independently. Now, we'll talk about HPC. So HPC, what is it? It's really how effectively, efficiently, and reliably you use computational resources that you have at your disposition. It's the way I look at it, it doesn't matter if you have 10,000 nodes. If you cannot use those nodes efficiently, you are not making good use of the resources.
Sure.
So yeah, so having my Jupyter Hub in Azure using Kubernetes and auto scaling, if you are running, you need more resources, you automatically have that set up for you. You run it just as you will do on your computer, just as you will do on your laptop, but this time we can scale up. Now, I have a general, a playground for everybody. If you need more or specialized kind of, you have special needs, I'm gonna create an instance of Jupyter Hub for you with the amount of resources that you need.
I see.
Yeah.
That leads into the next question really well. It's almost like you knew what the slides were. So I'd like to know so if you have kind of patterns that you repeatedly see then for users where there are outliers and then you try to address them, I would like to know from anyone on any of the panelists, what kind of patterns do you often see in needs of the researchers, stuff that you could identify and kind of treat in a more standardized flow?
I'm just going to chip in with a very quick observation. I've been working with researchers on artificial intelligence projects, and we have seen a spike over the past 2 years in a demand for textual analytics and natural language processing.
Okay.
And I'm going to stop with that and let others chime in.
I'll chime in. I'm not surprised that there's a growth in AI. I've been attending the supercomputing conference for a number of years now, and they've gone heavily in that direction. Whether it's training AI deep learning models or other types of AI, it's really the area of growth. Natural language processing. I have a prospective client who would like to use our HPC system as part of his research involves analysis of online posts like tweets or Reddit posts. But because we're not in a position right now to support our studio, he's kind of pulled back away from me a little bit. I think, well, I'll just stop there and let somebody else come in.
Is that in a, well, before you do, is that in a traditional or non-traditional discipline using the online social media posts?
He's a communications professor.
Oh, interesting. Sid,
Yeah.
one of our participants is asking about how folks generally do background prep and advise on those workflows for non-HPC projects.
Hmm.
Remind me
yeah.
to tell you the story of the international multilingual translation project for Proust.
Well, I'm reminding you right now.
Oh, is this an okay time to tell the story? Okay.
Sure, go for it.
Go for it.
Okay, so the French major that I was telling you about earlier brought what is basically my classical user pattern to me, which is I know the data that we need to wrangle, but it's kind of a mess. We've got lots of collaborators from all over the place. The twist on that variation was, and we're doing it on 2 continents in multiple languages. Everyone has their own communication preference. We're afraid that, like, with all these people editing this Google sheet, somebody's going to hit the space bar at the wrong moment and then we'll lose like massive amounts of data. What do we do? Like, the word that he used when he was talking to me was, we need a database. But what he really needed was a content management system with integrated workflows. And that was language that was completely unfamiliar to him. So I was explaining things like, you don't just need to think about what's happening to this spreadsheet, because you're also, part of the process of getting these translations through the system is people are manually copying it from folder to folder, and some of them are renaming it and some of them aren't, and some of them are updating the spreadsheet and some of them aren't. You need something that treats your files as an object and keeps track of the 7 different review steps and makes your life easier. There are tools out there that are meant to do this thing. They're largely coming out of the web publishing world, but people who started out on the research side and haven't done a lot of web publishing won't necessarily have heard of them. But that's, when he's describing a end-to-end workflow problem with various breakpoints in it, there are pre-built tools out there. In this particular case, we went with SharePoint because we had the campus license. It was there, it was free, and it has multilingual interface built into it.
Yeah, so I'm going to add to what Dana said by insisting on the point that it's generally, I think, a good approach to have the researchers use the tools that they're comfortable with, unless it's not really helping them do much of the work and they are willing to do the change. So if I'm advising somebody on any project or involving multiple people, what I do is, well, you will use the tools that you're comfortable with, but you have to organize yourself. And the way you do is, since people are moving data across, you must always have a source data that you preserve, because the data is the intersecting object for all the researcher. They may have different, different languages, French, English, but at the end of the day, they are being connected by that data. And if somebody were to mess up the data, everybody is in trouble. So get your source data, have somebody in charge, set rules on how people access the data, and when they get it, how they get it, keep track of who is doing what, so you can trace if there are issues. Because when you do research, you want to be able to reproduce things that you've done. You want to be able to track. And if you miss track of what you're doing, it's even hard to troubleshoot and find out where problems are coming from. So I personally, generally will encourage my researchers, what are the tools that you're comfortable with? Does it help you do your work? Yes. Okay, but at some point, when they start running into trouble, you say, okay, this is the problem. You need to move from here to there. because I found out that it's very difficult to take people off of what they are used to something that is new. It's really very difficult, except in cases where they see that they really need it and they've seen it themselves, then they are willing to put in the effort to learn new things. If not, they'll always go back to their old habits.
Do you see the same type of data being moved around repeatedly that is in a program or a system that they are familiar with, such that you can make a template, or something that in the case before, a manual or something that you can provide to the next research team that has a some amount of reusable stuff for their problem?
So I've come across situations where people have data and they use it quite a lot.
Mhm.
But yeah, they have their they have data sets that they use and they share among themselves. But what we've come to realize is we need a place to archive the data. So when they have their data archived, when they have their data archived somewhere that is taken care of, they can now have copies or copy whatever amount size of data that they need at a given time. If they need all of it, then we're going to set up a pipeline, a workflow for them to use their data continuously. But if the point here is to avoid errors and not being able to trace. This is from my point of view and what I've been seeing on my campus.
All right, thank you.
And Justin,
Yeah, go.
yeah, just an additional comment on the question on the slide.
Yes.
About templates and very common use cases, and also connecting back to David's point about someone who wanted to analyze social media data, uses our studio, but gave up on HPC. We had similar experiences. And so what I did with my teammates is I kind of mentally, it's not a formal grouping, but I looked at it and said, okay, these guys, they're going to process, they're going to learn how to do this. And so something like user guides and manuals are very helpful, especially if it's developed to an extent which works with specific kinds of data, such as a Twitter data set, which has 90 variables, and maybe they have 20 million records that they need to analyze. And it's quite easy to prepare a manual and help them. There are other users who just will not do it. So what we have done in those cases is we have expanded our team and said, here's a person who's going to act as a go-between the command line HPC systems. One of the systems that we access is at Rutgers University. It's only command line. Now they have other machines that are GUI driven, but for whatever reasons, the way allocations work, sometimes you are stuck to a machine which does not have a GUI. So what we have is an interim person, a co-researcher, who just does this part of templating how to take the data and what a person has running in our studio and get it set up as a batch job. So between the manuals and between a person who knows and a template, we are kind of making things work.
Okay, thank you. Yeah, these are good points. Dana just typed some stuff into chat about spreadsheets and the Box API. Do you want to talk?
Sure.
All right. Yeah, thanks.
So as part of the multilingual project, I really would have loved to let them stay on the system they were familiar with, but I got the Box consultant in, I got the Google consultant in. We spent an hour or two trying to find a way that was robust enough to let them stay on that current system, and the SharePoint mockup was just so much better and so much more stable. With we put an hour of time into each of them, and they could see for themselves the difference in the stability, the reliability, you can't just accidentally hit a space bar and nuke everything types of situations.
Sure.
On the template world, there is there's a lot of common use cases, but because who you are and where you're coming from makes such a difference in the access that you're going to get to our systems. I have a handful, it's like I have like 8 different sizes of screwdrivers, but I got to make sure that I talk to you to know which one is going to apply to your particular situation.
Sure. Which is that's why you have to have the intake interviews.
Yes.
Yeah. That we did in the last session, right?
Yes.
All right.
Like that is my bread and butter. That is step 1 on everything.
We actually have some audience questions. So I don't necessarily have slides for them, but I'd like to know. So you were just talking about data storage. What happens towards the end of a project? One thing that is often asked about is kind of the closure for a project process for the data management, and who owns that process.
So I'm part of the research data service at the University of Illinois. And while we have the Illinois Data Bank for publishing fixed sets of data that are meant to be reused as reference materials for documentation, that is by no means the only solution that we've got. There's some types of data that is just never going to be applicable for. It's very good for a fixed data set that goes with a fixed article. It is not going to be good for a dynamic, continually growing database. You can put individual snapshots in there, but like, again, this is going to be part of the intake and possibly exit interview process, is figuring out, so you've got your set of data. Now tell us about how durable the format is, whether it's open source or not, whether people are going to be releasing new versions of that format, who is going to be needing to see it, who is going to be not needing to see it, like who should never have access to the fun or restricted version, does it need anonymized before it needs published? There's a whole array of considerations that will go into figuring out the appropriate home with the appropriate durability and appropriate price point for data on the other end of the scale.
Sure, that sounds like a lot. This wasn't in the question, but I guess at what point in the project timeline should that be occurring?
I ask about it at day 1 because planning for it all the way along is important. I mean, I need to understand the entire life cycle on day 1 in order to be looking at the right systems with the least amount of hair tearing along the way.
Okay. So it's as far as assessing for the researchers, that is right up front, even though it's the absolute last. Actually, it's often after the end of the project where it matters.
Yeah, absolutely. I'm asking for it on day 1 for the same reason that documentation and security should be asked about much earlier than they frequently are in any given process. Because the way that you are naming your data, the way that you are naming series of file datas, like all of that goes into making your life easier when it comes to archiving. If you are planning for it all the way along, if you're naming your file structure in intelligible ways, if you're documenting your system as you go, your life when you get to the point of archiving it is going to be so much easier than when you're at the end of a 5-year project and looking back to year 1 and going, oh my God, like I don't even know who was doing that thing. Where was it? Whose folder was it in? Are they even still at the university? That sort of thing.
Sure. Are there types of, in your experience, are there types of data storage methods that tend to be more helpful for researchers? And does that overlap with what's maybe best for IT?
So that I don't think you can say for researchers. It really depends on the type of data and
Sure.
the volume of data and how collaborative their group is. I was part of a 13-person consultation about a massive set of Fox genomics data that had come from another university, and we worked with them extensively to figure out, does Globus work? Does AWS work? Does Box work? Does Google work? Who is going to need access for how long? If they don't get tenure, how are they going to move on? how do they get it from where it is to where it needs to be?
Yeah, so and those are really important things that you gather at the intake, because dealing mostly with infrastructures and facilitation. Yeah, when I have a chat with you and I figure out that, well, you really need a robust data management plan. In that case, on campus, I know the reference person or somebody who's well placed to help you and give you better advice than I can do. I will direct you to that person, exactly as Dana is doing and saying. You really need to think ahead of time. You don't want to get in the middle of your project and start thinking, oh, I knew, I, I hope I wish I knew about this. Well, it can really put a slow on your work as well. And as far as the type of data the type of data that people need is concerned, so I deal mainly with data that has been generated in the process of computing. You generate all of that, or data that is being collected from instruments. So people have their data from instrument and they want to probably move it somewhere or archive it and wait and think about what they need to do. And I usually ask from experience, when you compress your file, have you had any situation in the past where you compress your file and when you go over it and try to analyze it, where did you find out something was missing? Because if they have that experience, so if not, in order to minimize taking up a lot of space here, we are going to compress, and generally I work on figuring out what is the efficient or most effective way to compress data that is going to be archived, because sometimes they have to pay for storage and they may not have a lot of the resources to cover that, and you have to figure out ways to help them.
Sure. Thank you. Yeah, I know for electrical engineering here at University of Rhode Island, we end up putting stuff on long-term storage tapes. So having kind of a plan if that's gonna be kept for that long, knowing how to compress it, I can see being a pretty critical line item.
Hey,
We also,
Josh,
yeah,
this is Dave Apostle again.
sure.
Can I ask the group, after these plans are put in place to save the data and special care is taken that it's formatted correctly, is there ever a plan to go back and see if you can bring the data back from storage? I came from a information security background, and part of disaster recovery for businesses is to go through this step, and so many businesses don't.
Yes,
when
absolutely. That's part of our process. Yeah.
Okay. So how do you do that? Because often budgets, I mean, does that take a long time for a research team to reconstitute their data? Do they budget for that, both dollars and time?
So if it has gone into the Illinois Data Bank, we have a review at the 5-year mark to get, to take a look at each of the files that, each of the data sets that were entered that year and make sure that the things are still readable, that that the stuff still makes sense, that nothing has gotten corrupted, that it is still possible to spin up an environment that can take this data and do something with it. During the process of intake, if we see anything that is likely to be red flags, like I took a paper to Kyoto in 2017 about the problems with digital media types and the proprietary platforms, and how to make sure that things that were born digital can keep being used over the long haul. When the graphics cards change, the codecs change, there's I will not get into the point of that paper because that would take way too long. But yes, there's definitely a process, and we have data curators whose job it is to do that thing. And if you don't have data curators whose job it is to do that, then there's something called the Data Curation Network, which is a collaboration between lots of different university libraries. They're saying, hey, I have a specialist in this, you have a specialist in that. We can't all have specialists in everything. Let's pool our specialization resources and work with each other. And I think that's a pretty awesome thing.
That's fantastic. It sounds like you also collect metadata, like
Oh, yeah.
what version of software was used to compress this information.
Yeah.
Okay. Yeah.
Yeah. So
I would say that's advanced, very advanced.
Okay.
Yeah. So from the infrastructure point of view, especially, I'm not a librarian, so I'm going to speak from a research point of view and from IT perspective. So from my previous institution, so the approach was you have universities with common interests. They probably could have a data center for backup or archive, or some people have some sort of agreement. You have a copy of your data at my institution, I have a copy of my data at your institution. So that way you interchange. And generally, when the data, you're working with researcher who's planning on experiment or something, you work with them on how they set up their files. So if you are automating backup or compression, when the file is offloaded off the instrument, it's dated with some sort of tag to indicate who owns the data. And you have primary location where generally you have the attached a computer which you don't want any data staying on it. You take it off onto the server so other people can use the attached computer. And from the server, you can have a certain amount of time where data can stay there. And if it is not being used, because generally they will come back and say, oh, my grad students deleted everything. By any chance, do you have a copy? So data gets off that server, goes into an archiving system, which could be a multi-institutional archiving system or some sort of agreement between institutions where you keep a copy of your data at my institution and I back off at your institution just in case. And that way, when people want their data, you have a way to go back and retrieve exactly what they want. The name, approximately the date that the experiment happened. Yeah, you go in there and you pull that and everybody's happy.
Okay. Thank you. Yeah, those are those fit past the beginning and intermediate, I think, level for this, but definitely useful. And I'm interested to know at what point should you start talking to some of those resources, Dana, you had mentioned, where you can get some help on that retrieval process or assessment. And then we actually have a couple of more questions in the chat, one of which, or I think both of which you have already answered, but I do want to ask it after you answer that question first.
Oh, I apologize. I was typing while the question came up. Can you?
I know you're on point in the chat. So I guess my question was, you had mentioned a moment ago that there are resources to help both the cyber infrastructure facilitators as well as the researchers through that process of validation of the data.
Yep. Talk to your libraries. Talk to the folks who are doing the digital archiving. Talk to your library schools if you have them. We are fortunate to have both an excellent library school and an excellent library with a lot of digital media specialists. We have a system called Medusa, which is used as our university repository, and they do a pretty extensive job of checking things that go into there so that we know what to do with them when they're in there and what to do with them when they come back out.
I see.
It's not necessarily easy. It's going to take, a fair bunch of work. But sure, if the return on investment is high enough for you to want to be able to open this 25 years from now, then spend the time on this end to future proof as much as you can and send up the flags to recheck that every few years, because what I was guessing in 2014 was going to be the way that the digital video world went was totally not the way it turned out to have gone when I did the follow-up interviews with these people in 2017. And what they were guessing, they were going to need was totally wrong. So that's why the recheck is going to be important.
Sure. Early and often.
Yes.
And that actually fits into one of the questions, which was, what do you think that compute infrastructure might look like in 5, 10, or you said in 25 years for an HP ecosystem? And how might what should these communities do to get there? And how might those help social scientists?
Is that from
let's say-
Corina?
What's that?
Is that a question from Corina?
Yes.
Yeah. Yes. So I'm going to go back a little bit at my days at the graduate school. So I was in a group specifically working on developing computer programs for quantum chemistry and having interactions with computer scientists that was at the University of Tennessee, Knoxville, and Oak Ridge National Lab. So one of the jokes that the computer scientists will make about us were, do you really care about how you program, or you care more about the work that you're doing? And my answer to them is, well, I'm doing what I do because you don't care about writing good program for me. So the point that I'm trying to make here is the scientists or somebody in the humanities, they have a problem to solve. And they want to solve it as efficiently and effectively as they can, but they have limited skill set to do that. They understand the science, but they don't have the skills to solve the problem. So one of the ways we did was we partner with people in computer science. And in my research group, I had people doing PhDs in computer science, people doing PhDs in physics. There was that constant communication and sitting down discussing about ways to really write efficient program. So if you are in the humanities, you have your problem, you explain the problem that you want to somebody who's in computer science, who understands computers, they understand the language. Now, there will be some challenges at the level of vocabulary. What is the meaning? I'll take one simple example. In chemistry, for example, if I say basis set, the chemist knows what I'm talking about. The physicist, it's probably something completely different. He probably, and most of the time, they have no idea what is it. It is. To me, as a chemist, it's just a way I represent a function. But in reality, to the physicist, the basis set exists because it's a numerical representation of a function, which is a great point. So you have that communication with the expert in computer science. They understand the computer, they know the program. Now express the problem. They can write computer program to solve your problem, but does the result make sense from an experimental point of view? Can you interpret what they have? If not, you have that communication again. This is fiscally, this has no fiscal meaning. And it could be because of this. And then you have a number of hypotheses that you straw over and figure out ways to fix. So I think there is a future for that. And there is work for everybody there. If the scientists in the humanities work together with people in computer science or people who have background in computational science. I quite remember, I'm not way too old, but when I was starting, there wasn't, in biology, for example, people didn't use a lot of computing. But as time went on, and most of the computing, and if you look at most departments at institutions where the computational science started, it's probably in the chemistry department where they had their own cluster and now everybody wants to use it. So it wasn't always everywhere. It grew because people understood the need of using computer. And if there is that communication between the scientist who has problem to solve and the expert who has skills in computer science, well, they can solve the problems together.
Thank you. You're also mentioning the distributed resources, kind of how as an outgrowth of a need, universities and institutions kind of started building those systems. In your case, in the chemistry departments. One of the questions from a whiles back in the chat was about what are some of the specific techniques that a centralized IT department could do to assess the broad research needs in order to develop and deploy centralized research IT services, so that you kind of have a most bang for your buck, that where when you have resources, that they get spent by the institution in a way that best addresses the needs across the institution.
Yeah, I think there needs to be a conversation, and I think that's a problem that I personally am facing. So I work in a central IT, and when I joined the central IT, there wasn't anybody who had an idea about research computing, but individual departments have IT staff, people who help with IT related needs, and they're working in isolation, and people have a server here, a server there, and when you look around, it's really a waste of resources, because when that server is not being used, somebody probably somewhere wants to do some work and they can't do it because they don't have access to those resources. So there needs to be a conversation at the university level. So what I propose at my institution is have a panel of faculty, because I don't want to make decisions for faculty. They are the one using. So I'm just making suggestions, and have a talk with the AVC or the vice chancellor for research. You have that discussion, and then they bring in faculty or department heads, they have the conversation, and they have a strategy. So in my case, I propose, well, it would be great if we can bring all the resources together, and in such a way that people can have access to these resources when they need it, how they need it. And one other important point is, what I noticed was when somebody had a grant and they had requests for some server, they would just go and have it in their department, set it up, they run it up, beat it until it's tired, it's no longer doing anything. That is not really productive. If we had an HPC, centralized HPC, or where people can buy in, they can bring their own cluster and have priority over the resources, how they use, that would be great. But generally, it's sometimes very difficult to convince people to buy into these ideas until they've seen something practical. So if what you're suggesting cannot work, what I have proposed is get a few people. You could have 2 or 3 faculties who are willing to try it out. Have them use it, and then use them as ambassadors, and then sell the idea to the rest.
Interesting. Those are great ideas. I want to know, so about where are you in that process? You said you've started it?
Yes. So I've established a research technology facilitator network. So I've contacted people who help in various departments. We come together, we exchange idea, we share experience, how we approach solving problems, and we discuss. I get to learn about what is going on in various departments, because they are closer to their department heads and the faculty than I am. I'm almost like an outcast. So, and if I want to learn more about the department, I really have to go close to the department. But I cannot really, the effective way for me is to bond with people who are already present in a department, in a way that I can learn from them. And then I act as an intermediary. So when I'm talking to the associate vice chancellor for research infrastructure, these are what I hear from people, and I hear the minutes. This is what I gather. This is what people are talking about. This is what people need. That gives you a sense of what people really want, and you make decisions from the bottom to the top, not you deciding and having people to say to take it or leave it. So I really would like to hear from the user, because everything we put in place is for the researcher. And if they can't use it, what is the point of even wasting your time on it?
Sure. All right. I think we talked about a lot of great suggestions and things that are going across from different institutions on how to assess and address various researcher needs. I think we're just about running out of time, actually. But I like to thank the panelists, David, Jim, Deval, Jacob, and Dana, for their insights and thoughts. And if people want to reach out to them, I believe some of them have their information posted. And I want to thank everyone for your questions as well.
Thanks, Josh. It was a good panel. Thanks for leading it.
Yeah, thank you very much. Thank you, George. Great discussion.
Excellent discussion. Well, you guys did great. Thank you.
Thank you all for a wonderful panel and some virtual applause from all of us. We're going to pause, and then we'll be back in production in about half an hour at 1:15, at which time we've got our next session, which is, hang on, I'm looking quickly. Broadening the constituency via outreach and communication. This is an advanced panel. It's going to be a lot of fun, and we'll learn a great deal. Thank you very much, everyone, and see you in half an hour.